Experiments done with carbon-12 isotopes. Scientists wanted to standardize our communication. So when we talk about the quantity of things, we can get the ratios correctly. So for example, for every dozen eggs, I need a dozen slices of toast. My ratios will be 1 to 1. And that word dozen is a number in our head right here. When I say the word dozen, or when you hear the word dozen, you can think of a number immediately in your head. If I say baker's dozen, it's a different number. The number that chemists decided on right here was, like I said, based on some carbon experiment, slope of a line, was a word called the mole. They determined and came up with this word, the mole, which has I think it has a Greek or I'm sure it has a Greek or a Latin derivation of molecule or something like that. But 1 mole is equivalent to 6.02 times 10 to the 23rd. So to say 1 mole is a very lazy way to say 6.02 times 10 to the 23rd, but also much easier to communicate. I have 1 mole of this, a half a mole of that, 2 moles of this, 2 dozen, 3 dozen. Okay, is it easier to say 24 eggs or 2 dozen eggs? So it's easier to say 1 mole is 6.02 times 10 to the 23rd. So let's look at that. How many moles is 100 trillion plutonium atoms? How many moles would that be? To say 10 to the 24th atoms is not how chemists talk. We talk in terms of moles. So let's set up a scaffold to solve for how many moles of plutonium atoms we have here. So we have 10 to the 14th plutonium atoms, and 1 mole is equivalent to 6.02 times 10 to the 23rd atoms. Now, we could be talking about plutonium, we could be talking about hydrogen atoms here, but we have atoms canceling out. So now everything cancels out. So now I need a calculator to get this down here. 10, I gotta be real careful with my parentheses and how I divide. I'm going to put this in standard notation. One, two, three, 4, 5, 6, 7, 8, 9, 10. Okay, I think I have that written down there correctly. So this is a very small number. This is 0.0009016 moles of plutonium atom. So that speck of dust is 100 trillion plutonium atoms, or you could say that speck of dust is 10 to the 14th plutonium atoms. Or you could say it is this many moles of plutonium atoms right here. And this is how chemists communicate. They communicate more often in this unit of moles as a ratio of comparison right here. Now this unit of moles is helpful because there is a unit on our periodic table that relates the moles of an element to its mass in grams of how much it weighs there. So on our periodic table, there is a number below every atom that has the units of grams per moles. So we said that 1 mole is 6.02 times 10 to the 23rd of anything. So if you have 1 mole of plutonium, where is it here? 94. If you have 1 mole of plutonium, it equals 200. Now my periodic table right here has the 244. I'm in parentheses. I'm sure there might be a more accurate number out there, but 1 mole of plutonium is going to weigh 6.02 times. I'm sorry, what is that? 1 mole of plutonium is going to weigh 244 grams. and that is off the periodic table. This number here has the unit, grams per mole. So this is a true statement only about plutonium, only about plutonium. For other elements with different numbers of protons and neutrons, it's a different number. So this is how many moles we have. If 1 mole equals 244 grams, and this is much less than a mole, and we're talking about a speck of dust, I bet we have a grams that is really small, because a speck of dust can't weigh more than a thousandth of a gram, something like that. So this is how many moles we have. This is 1 mole equals how many grams. The grams of plutonium, how many grams of plutonium does 100 trillion weigh? Remember, 244 grams of plutonium is 1 mole all day, every day. I'm going to put the 1 down there for clarity. You won't see that 1 written often, but because I have this written here, I'm going to try to that consistent. But I have that green there, that green 1, because you're rarely going to see a 1 in there. Sometimes you feel more comfortable putting a 1 in there. And remember, dividing by 1 doesn't change the math, so it's not a bad thing to put it in there. I want moles to cancel, have this number up here, 0.12345678916 moles. I have moles canceling out here. So it's going to be how many grams? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 6 times 244. 3 times 4, 2, 3, 4, 5, 6, 7, 8. 4 times 10 to the negative 8 grams. So now remember, this is a speck of dust. It is very, very tiny. Even though it contains 100 trillion atoms, it is a speck of dust. So it should weigh a very, very tiny amount. This is how many grams of plutonium are present in that speck of dust right there. 4 times 10 to the negative 8 grams. Now we are on the precipice of our question that begat this whole thing. Plutonium on eBay, plutonium is $5,600 per gram. Yeah, I think I'm pretty sure I found that on eBay. Maybe Amazon. Maybe it was Amazon. 56. If you got Prime, you should definitely buy it off Amazon. Plutonium weighs 56. Sorry, the cost of plutonium is $5,600 per gram. How much does this grain of dust going to cost you? Let's write those numbers down and put them into a scaffold. We want our final answer. Board's getting a little crowded here. I think I can fit this in here. We want our final answer in dollars. So we said that $5,600 per gram is the cost of plutonium on Amazon, not including shipping. And again, I have the 1 here in green. You're not going to see the 1 in a lot of textbooks. You may see it in a lot of other content creators, but it helps you feel comfortable. I'll put the 1 in there. We have this many grams. I'm going to put this in standard notation because I have the room. 1, 2, 6, 7, 4. Grams of plutonium. So now, when we calculate this out here, grams will cancel out. We'll be left with dollars right here. We're going to be left with a very, very tiny dollar amount. I hope this helps. Thank you so much.